Bismillahirrahmanirrahim. Assalamu alaikum everyone. That is Arabic for peace be with you all. I'm Imran and today we have a Nintendo Switch which has no power. It actually came from another shop and it came like that. Like this. In tiny little parts. Everything has been taken off. Looks a bit water damage here. Let's focus, as you guys probably can see at the corner here. Memory card, reader. Well, we've got some screws in there. We don't know if they are all or there's some, if there are any missing, but we will see to it after we have fixed that. So let's put that aside. Motherboard been taken off. The fans and the heatsink's been removed and bent. Okay, this is not good. Alright, so let's see if everything else is okay. Yep, it is. We have a game card as well. So we'll put them aside as well so that we don't lose them. The game card reader. So the story behind this that I've been told is that the customer brought it in for charging port repair, that it is not charging, and the guy who brought the phone to me, sorry, not the phone, obviously the Switch to me, he said that he had replaced the charging port and it didn't work. Now, according to him, he tried a different battery as well, but it did not turn on at all. So let's take a look on the motherboard under the microscope and we'll go from there. Okay, microscope. Well, what do we see here? A missing chip, a melted connector, let's take a look at the pins if they are connected properly. So this one is not. And all of the others are perfectly joined to the motherboard. So the problem with this charging port is that you see those pins here. It's a type C charging port. So there is another layer of pins under here which you cannot see. You cannot remove the metal shield and get access to those pins, because those pins of even if you remove the metal shield, the pins are under the plastic, that black plastic thing. So there is no way for me to be sure that those pins are perfectly joined. So I'll probably be removing that charging port off, make sure everything is connected perfectly fine, and then we will go from there. But for now, let's take a look if they have damaged anything else. Looks okay. Let's take a look on the other side. Alright, so nothing's broken on the other side as well. So we have our charging port, the missing chip, and I don't think that this chip has anything to do with the Nintendo Switch not turning on. So let's just go ahead and take a few readings. Put the multimeter in continuity mode so that when the two pins connect it beeps. Okay, so these are the caps are fine. Okay, right, so there we go. This one here is shorted to ground, that one is not, and that one is shorted to ground as well. This one is alright, and that cap is shorted to ground too. That is enough for me to consider that M92T36, that chip is faulty, and this is the one that usually gets messed up, this one or the one over here, that chip. Sometime it is not even that chip, it is not even that IC that is faulty, but this one over here, PI3 USB 3532 ZLE. So what I'm going to do now is I'm going to take off the M92T36 and then I'm going to test if the short is there on those capacitors, that capacitor and that is not a capacitor, that is a filter or a fuse, whatever you want to call it. So let's just go ahead and remove that chip. Always remember the orientation of the chip before removing it, because for these things we do not have schematics, and if you do not have another motherboard and you forgot the orientation, then it'll be a time wasting process to find out. You can find pictures over on the internet, but obviously it'll take your time. So we have our orientation dot here on the top left corner. So what we will do is we will remember that it was on the top left corner of the chip. Okay, so the chip is off. We're not going to throw that chip away just yet. We need to make sure that this is actually the culprit of our problem. Okay. So we're going to go ahead and put one multimeter probe on the ground and the other on the panels again. Okay, so we have eliminated our short. We're going to check it over that cap as well, because this one was shorted too, and it is still shorted, which means that this might be faulty too. So let's go ahead and remove that as well. So the orientation for that chip is bottom left, for the other one was top left. Okay, so we have removed the PI3 USB. This is a USB switch for let it cool down a bit so that the measurements we'll have will be much more accurate. And the short is gone. So what does that means for us? That means that both of them chips were probably faulty, or the first thing we were supposed to do was to remove that charging port. As I said, I didn't trust really the charging port, so we should have done that first, but we didn't, so let's do it now. So what I usually do with that type of charging port is I bring it to the side of my table and I heat it up from the bottom, just like that. Once the solder starts melting, I will try to pick it up, and there we go. We have our charging port removed, and the charging port looks fine. The pins were all seen to be connected except obviously that one, the one we tested at the very beginning of the video. Okay. So what I'm going to do now is I'm going to put that chip back on, M92T36, to make sure that this was not the problem. Bit of a flux to flow it back onto its place. Okay, chip is on. We are gonna let it cool down a bit again. Okay, so we have our short back, which means that this chip has gone bad. So there was absolutely no point putting it back on. Okay, so what we're going to do is now we're going to take that chip off. We're going to put a new one on in its place. Okay. Let's put some leaded solder on before we wick the pads. Okay, that is done. Let's take our wick and let's clean the pads up. Okay, and that is cleaned, nice and shiny. IPA, isopropyl alcohol, 99%, to clean up the rest of the flux. Okay, that's done. Put some new flux on. Right. Time to tin the pads. Let's get them ready for a new chip. So we have our M92 T36. Over here. Let's go ahead and put it on. Let's heat up the motherboard first. Align the chip a little bit. Heat it up. Put some flux. There we go. Have our chip nice and aligned. Now we're going to push it down in the middle a little bit to make sure we have nice shiny joints. Okay, got that. Let's clean up that solder on the side of the chip. Gotten rid of that. There we go. We have a great looking chip on. Let's clean it up a bit and then we will test it. Let's get our brush, some alcohol. Okay. Now let's test the same points again that were going to ground before. no beep, beep, no beep, no beep, beep. So this means that this one is perfect. Let's check the one on the back. No short, so that is fine too. Now let's go ahead and replace that chip as well. A bit of a flux, that's more than enough. Let it solder. Okay. Fresh bit of flux to tin the pads. Okay. All right. So we have our new charging block, as you guys can see here, nice and shiny. So what we're going to do is we're going to tin the pads before we put it on the charging port as well, because this is the only way for me to make sure that every point makes a nice joint onto the motherboard. So that is done for the back pins. Okay, so now we're going to go ahead and fresh flux on. Now we're going to get that under here, and we're going to start heating up the motherboard from the back side or the bottom side, because from the top I cannot make sure that every point is joined properly or reflowed properly. So what we're going to do is we're going to do that heat up from the bottom of the motherboard, because I can make sure that this row here is joined perfectly, but what I can't see is if they are joined properly. And if I heat up the charging board from the top, it will melt all the plastic in it before it will reflow these solder joints. And I do not use low melting point solders because they break up easily. So we can see that we have our points melted. Now we're going to put our charging port on. As you can see, it has reflowed nicely on. I'm putting a bit of a pressure just to be on the safe side, to make sure that every point is connected properly. So once that is done, we're going to go ahead, take a look at the pins here. All of them are well joined nicely. Now we're gonna go ahead, take our soldering iron, and we're going to fill up these points over here, the solder. These are the points that actually hold the charging ports in place. So we'll fill them up nicely. That is done. And we will fill up those back 2 points. And these two. And if you take a look from the other side now, we have a nice and shiny looking charging port connected to it. One thing I'll want to make sure before I plug it in to the power source is that this chip is working fine. So okay, so this pin seems fine. There is no short on one of those big caps. I'm just touching up on the big cap because they are obviously probably responsible for the power rails. So if none of the power rails are shorted, it would probably be okay. So with that said, let's clean up our charging port. Dry it with the tissue. The back side as well. Dry again. So it is nice and shiny now, as you guys can see here. Perfect. Let's go ahead and put it in, but before we go ahead and do that, let me take the measurement of the battery voltages. To make sure that it is not completely dead or over voltage, or sorry, under voltage, not over voltage, under voltage. And we have nothing in that battery. I was expecting that because obviously two of the chips were shorted from the main power lines that were turning those chips on, so it can result into a completely dead battery because of the short. So now that we connected our multimeter probes, one to the red pin and the other to the black, we read nothing on the multimeter, nothing at all, which means the battery is in hibernation mode. So to get it out of hibernation mode, we're going to supply power on these two pins, one to the negative terminal and positive to the positive terminal. And then we're going to turn on our power supply, and it is taking 1.4 amps. We do not need to supply the power for a very long time, only a couple of minutes would do. So I supplied 4.1 volts for about 2 minutes, and now we are going to disconnect our power source. We're going to put in the motherboard here. Now I'm only going to connect the necessary connectors for the switch to turn on. I mean the backlight and the screen connector and the touch connector. Other than that, I will leave everything off because this is just a test to make sure that it is turning on. So once we know that it does turn on, we will then go ahead and connect everything else. So this is the power button and the volume connector. This is for display and touch. Okay, that's in. This one here is for the touch. Okay, so let's go ahead and connect the battery. Battery is connected. I'm going to plug it in to the power source, to the charging port. And there we go. We have a battery charging sign, which is a good thing because before it was completely dead. So we're going to leave it on charge for a while, and then we will come back and show you that it is working perfectly fine. Alright, so we have it turned on here. As you guys can see, it is 11% charged and charging, working perfectly fine, no issues at all. That's it for today's video, and as usual I hope that you guys learned something, and I will see you in the next one.